All right, so watching at home, I want you to do the increasing and decreasing intervals for this function. Here's a little the flow chart that we've been working on or thinking about, and we want this piece of it. So we'll take derivative, and that'll kind of get us started down the path. So derivative of x is 1, derivative of 9 over x, I don't want to mess with. If I rewrite it as 9x to the negative 1, then I can get out of doing the quotient rule, and it's minus 9x to the negative 2, or 1 minus 9 over x squared, if you prefer. Let's see, critical points are where f prime is 0 or undefined. I'll do the undefined first because that's the easy one, at least for this problem. If x is 0, I've got a problem. So x equals 0 is one of my critical points because y prime is undefined there. If I set it equal to 0, then I've got a little bit of algebra to mess with. Let's move this over. So 9 over x squared equals 1. So x equals plus or minus 3. So I've got 3 critical points, 3 possible extrema. But I don't, this equation or this problem isn't about possible extrema, it's about intervals. So I'll set up my number line with those 3 values in numerical order, right? Don't put them out of order. And then I'll test the intervals. So negative 4, negative 1, 1, and 4. And again, you pick any value you want as long as it's on that interval. And we want to test it into, I guess we're in y instead of f. We want to test it into y prime because the derivative will tell me if it's increasing or decreasing, if the original function is increasing or decreasing. So at negative 4, 1 minus 9/16. And again, all I really care about is positive or negative. So I don't really have to worry about common denominator. It's 1 minus 9/16 is positive. So that means y is increasing. If you want to see a picture of it, you can do the little arrow because y prime is positive. Right, if I plug in negative 1, 1 minus 9 over 1, that's negative. So that means y is decreasing. Again, I don't have to have the picture, but for some people the visual of what's going on is helpful. If I try 1, again into the derivative because I want to know if it's increasing or decreasing. 1 minus 9 is negative. That's also decreasing. I'm just extra careful here because with polynomials anyway, it usually alternates. It usually changes plus minus, plus minus, plus minus. But not always. So that's one of the reasons I picked this problem is I don't want you to get in the habit or get used to seeing them alternate and just think that that's always the case. It's not. It's usually the case, but it's not always the case. And I plug in 4, 1 minus 9/16. Again, fractions, but 1 minus 9/16 is positive. So y is increasing. So I think I found a max and a min, although that's not what the problem asked for. It just wanted increasing and decreasing intervals. So it increases from negative infinity up to negative 3, and then 3 to infinity. And it decreases. You need to be real careful here. For some problems, you could shortcut this and say, oh, it just decreases from negative 3 to 3. I don't want to say that because this thing wasn't even defined at 0. So I can't say it decreases from negative 3 to 3 because there's nothing happening at 0. So I think I'll just leave it as it is here. It decreases from negative 3 to 0 and from 0 to 3. Another way to say this would be if this graph was continuous, then I could just say negative 3 to 3. But something weird is going on at 0, probably an asymptote of some sort. So I need to break it up. So there's my decreasing and increasing intervals. Again, naturally leads to discussions of maximums and minimums, but that's not really what the problem asks. What we're going to do today is kind of an extension of this. Thank you. Yeah. I shouldn't say an extension. It's the same. It's the same process with the second derivative. That's the easiest way to say what we're going to do today. All that work, we're going to take a second derivative and do all the same stuff.